Welcome to my channel Techie Sang. In this video, we are going to discuss about embedded product development life cycle. If you are new to my channel and if you feel that my channel is interesting, kindly subscribe my channel. Embedded product development life cycle. Now, when you start a product, if you want to design a product, you have to plan the life cycle of that product. It should be in a structured process. So from the concept till maintenance, that is after deployment, you have to go for maintenance. Till maintenance, you have to plan everything while designing a product. Whatever might be the product, first you have to, from concept to deployment and also maintenance, how we are going to maintain that product, everything we have to design it. We should have a clear picture of it while developing a product. That is embedded product life cycle. Now getting into this one, simple thing is that it comes under embedded system. It is a structured development life cycle. Okay. The procedure is, what are the procedures that we are going to do it for product design? It is done for all the products. Okay. In industries, we have seen in previous lectures, it is used in automotive, health, and consumer electronics. Okay. If you consider a life cycle of a product, what are the things we have to consider in case of product? That is what we are going to see. The first thing is requirement analysis. You should know what are the inputs that you're going to handle, what is the output. You should know all possible combinations of input. If at all, if you doesn't know, if the combination is very big, if for example, if it is 2 input, the combination will be the combination that you have to consider, all possible combination that you have to consider is 2 power n, 4. Okay, n is equal to 2 and it will be 4. So 4 will be the all possible combinations of 2 input. Similarly, if you have n input, the number of combinations will be 2 power n combinations. Okay. If n is very big or larger in size, in that case, it is very difficult that you cannot calculate all possible combination. But you can differentiate what are the inputs that is required and what are the outputs that is not required. What is the input that is required and what are the inputs that you will not use it. And the worst case scenarios for the inputs, that you have to plan it here itself in the requirement analysis. Second thing is system specification and architecture design. Okay. System specification. You have to design, it is a co-design system. So in this case, what you have to do is, it is a co-design. You have to design, you have to undergo software development as well as hardware design. Both you have to take care here. So in architecture design, what you have to do is that you have to design which portion should go hardware and which portion should go to software. Now, the modules will be if it is a very big project, you should have an idea. You should frame initially what are the modules that you're going to move it to hardware and what are the modules that you're going to move it to software. That you have to decide earlier itself. That is architecture design. Once you have partitioned software module and hardware design, in that case, software, whatever the modules that is partitioned to software, that will take the path of software design cycle. Whatever the module that takes whatever module that is considered for hardware design, that will be considered for hardware design. So after completing hardware and software, these two things has to work together. That is co-design system. hardware module as well as software module has to work together. So you need an interface that need to be generated between the hardware to communicate between the hardware and software. For that, we have to design an hardware software interface. And then you have to integrate. After integration, you have to go for testing. You know how many inputs are there. You have to test it for all possible combination. If at all, you have to consider which are the portions that are very important, which is the worst case. Everything has to be tested in case of testing after integration. And then it is validated and also it is verified. After verification, the software portion will sit in the processor and the hardware portion will sit as system on chip or hardware or whatever the module that we are going to design it. And then we will take it from production, and whatever may be the application that will be deployed and checked in the production. After checking if the product works, then we will go for maintenance. Then we will go for maintenance and also update. Okay, this is what we have explained. I have explained it in the previous segment. Requirement definition. Okay, you have to analyze the market. You have to get all requirements from the customers. You should have all possible combinations. That you have to get into specification. Now here, from specification, you have to go for architecture development. Here you have to partition software module and then hardware module, and to interface to communicate between software and hardware, interface need to be designed. For this interface, you need a software driver and you need hardware interface synthesis. Once all these three modules are designed for a product, it is taken for integration and testing. Now, integration and testing will have software module as well as the hardware module. Both it will have. Okay. The components will be reusable components. Everything we have to take care here itself. Okay. This is the life cycle overview. Now, if you simple thing, we will take it. The approach we will take it. User requirement, you have to understand it. Choose optimum electronic chip, whatever hardware that you're going to use it. Okay. In this case, whatever electronic chip already available chip, there are different electronic chips that is available already. Okay. That chip we have to choose it according to the product. And what are the modules to be implemented in software side? What are the modules to be implemented in hardware side? Both has to be decided here itself. Software will take up. You have to define the algorithm. You have to code it, compile it, assemble it. It is converted into assembling and then assembly language. And then it is taken for debugging, testing, simulation. If the output is not achieved, it has to you have to edit the coding. Again, it has to come to simulation. Once the software portion is achieved, it will be taken into this portion. Now, if it is hardware, what we are going to design is that we are going to design a PCB layout by assembling all the components and then testing. The hardware portion is ready. The software portion is ready. Both has to be deployed into in-circuit emulator. So the functionality is checked in the in-circuit emulator, and then it is deployed into embedded product. This is one way of doing it. Now, previous chart, whatever that we have seen in hardware software code is right. In that case, it is very costly that You have to design the software, you have to design the interface, and you have to design the hardware, everything you have to design it. And the cost will also be very high. But you want to go for optimum price, then you can take up this model.